Assalamu alaikum students, welcome to my channel Cambridge Companion, and today we will do the question number 3 of the Cambridge A and AS level chemistry 9701 October November 2024 variant 22. So we are doing question number 3. Nitrogen and phosphorus are the elements um, in group 15 of the periodic table. Nitrogen is found in inorganic compounds such as nitrogen oxide, NOx. It might be NO2 or NO3, okay, nitrates and nitric acid. Identify one natural and one man-made occurrence of the nitrogen oxide in the atmosphere. Natural, something like lightning. Lightning. All right. Now another man-made uh, internal combustion engines. Internal combustion combustion engines. So another question. Uh, Write an equation to describe the role of the NO2 in the direct formation of the acid rain. So role of the NO2 in the direct reaction. Okay, NO2 react with water plus water which gives HNO2 HNO2 plus HNO3 H and O3. But uh, we must check the equation. The products are correct, but either is equation is balanced from both sides. Um, I think it's not balanced. We should make it to balance. All right. I think we have 2n in the product side. If I put 2 here, the left hand side to the right hand side, I think it's 2 nitrogen, 2 nitrogen. I think 2 to the 4 plus 5 oxygens. Yes, there's 5 oxygens. Um, or 2H. Okay, now is it balanced? Okay, now is it balanced? Now, part three of the question is peroxyethyl nitrate (PN) is a component of the photochemical smoke. So describe how the PAN forms the NO2. All right. So how PAN forms, and I think it allows, or it reacts. It reacts with unburned hydrocarbons. Unburned hydro. It's all right. This is the. I think it's. We have another part. Nitric acid reacts with uh, basic oxides to form nitrates. Nitric acid reacts with calcium oxide. Okay, write an equation for this over. Nitric acid, which is HNO3, H, H, and HNO3, which is a nitric acid, plus calcium oxide, CaO, CaO. What it gives to us? It must be calcium nitrate, is one of the products. Ca, mm, mm, and what we will get? Another product is water plus water. Another part of the question, part 5, describe what is seen when the solid calcium nitrate is heated strongly. Brown gases, I think the observation is the brown gases. Okay, brown fumes. It should be capital B. Brown fumes given off. All right. The another part B of the question number 3 is a common test for the nitrates is the reaction with sodium hydroxide with aluminum. Equation 1 shows the reaction. It is the nitrate ions, aluminum ions, hydroxide ions, water, which gives ammonium, ammonia, and aluminum hydroxide. Reduce the oxidation state of the nitrogen in you is, if you are familiar with, to find out the oxidation states. So oxygen state is, which is -2, and -2 multiplied by, there are three oxygen atoms or molecule of the oxygen. Um, 3 into 2, uh, 6, all right, -6, or after, if I will shift it after this equals to, it will be +6 and -1 here, -1 here. So +6 -1, which is right, plus +5. You know, the oxygen state of the oxygen state, which is -2 oxygen. Oxidation state is -2. -2 which is 6. -6 after I will move there, which is +6 minus this uh, -1. So it means it, we get a +5, the oxidation state of the nitrogen. Identify the species that is oxidized in equation 1. So, what is the definition of the oxidation? It means it loses electrons. It means it is oxidized. Okay, or gaining in oxidation. Uh, Gaining in oxygen is called oxidation, or gaining the hydrogen is the reduction. So, in this case, um, what uh, aluminum here, that is oxidized in equation 1. I think aluminum gain, you know, oxygens here. Yes, yes, I think aluminum is the right answer. Aluminum, I just writing Al. All right. NH3 is a basic gas. The another part three of the P. Uh, NH3 is a basic gas. Describe how NH3 is able to act as a base. Zinc is an acceptor of the positive ion. Sorry. Uh, NH3. I think I should must be right. The text form. So NH3 is a proton acceptor. Is an proton acceptor like this. Alright, the proton acceptor, H-ion acceptor. Suggest the shape of al aluminum hydroxide, the negative ion is AlH4. It means it's tetrahedral. 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 So another figure 3.1 shows a sketch of the energies of the phosphorus. The first, second, third. Construct an equation to represent third ionization of phosphorus. Third represent third ionization energy of the phosphorus. So it means third ionization energy with P positive 2. So gas form. This gives this is the third ionization energy. All right. So we have complete the graph in 3.1. Um, Complete the graph in the 3.1 to show the sixth ionization energy. Sixth ionization energy. Mm, yes, think it's which you must be draw, but you clearly must shown uh, which group the phosphorus belongs to. Phosphorus belongs to the group 5. So, so we have the largest increase in the between the fifth and sixth. So you can draw anywhere. But be careful. There's a larger greater distance. Okay, I draw should here. You might be draw from anywhere, but make sure the I think I draw in an incorrect manner. The pattern. Um, yes, because it I draw from here. Make sure the greatest difference in the ionization energy. Please make sure. Okay, so part D. Uh, Complete table 3.1 shows the properties of the nitrogen and phosphorus in the standard states. Um, Nitrogen is a colorless gas. Electrical conductivity. Nitrogen electrical conductivity. I think it's poor. No, it's not good conductor for the electricity. Type of bonding. Covalent. Simple. And what about phosphorus? Covalent? Yes. Type of the structure simple. It's also a simple. Phosphorus is also a simple. Right. Move to the next party. A form of the solid nitrogen has the lattice structure similar to the solid iodine. Identify the type of the lattice structure of the solid nitrogen. Solid nitrogen. Think simple, molecular. Another at very high temperature and temperatures, phosphorus can form P2 molecules. P2 contain the triple bond. Describe the formation of the P triple bond P bond in the terms of the orbital overlap. I think one sigma bond. Okay, um, one sigma bond. Uh, overlap. You know, overlap. Uh, add on. Overlap. P orbital. Okay. Um, and two pi bonds. Two pi bonds. Two pi bonds. Side on overlap p orbitals. side on, overlap, p orbitals. Okay, the bond energy P triple bond P is 485 kJ mole. The bond energy is nitrogen 10 triple bond E 940. Okay. Compare the reactivity of the P2 and N2. Explain your answer. I think P triple bond P is weaker. P2 is more reactive than N2. P2 is weaker than N2. This is just simple. So, students, we have done question number 3 of uh, October November 2024 chemistry essay in A level variant 22. So please like and subscribe my channel. So we will meet in the another video. So please like and subscribe. Like my video, subscribe my channel. Thank you very much. Allah Hafiz.